Hello, guys. Welcome to Engineers Academy. Do hit the subscribe button if you are here for the first time. Now, we are going to solve this problem from chapter 16. The problem says that the link AB has an angular velocity of 3 radian per second. Determine the velocity of block C and the angular velocity of link BC at instant theta equals to 45 degree. Also, sketch the position of link BC when theta is 60, 45, and 30 to show its general plane motion. So we are given that this link AB is moving with an angular velocity of 3 radian per second in the counterclockwise direction. So if this link AB is moving in the counterclockwise direction, so this block C will move towards the left. So first of all, let me define my coordinate system. So our coordinate system is like this. So towards the right is our positive x, and in the upward direction is our y direction. So as I have discussed that when this link AB will rotate in the counterclockwise direction, this point C will move towards the left. So we can show that VC here. So this is that link BC. This is the free body diagram of that link BC. So we will have VC velocity, the velocity of that block C towards the left. So this is VC. And similarly, as we know that this point B is moving only in a circular path since it is revolving around this fixed point A. So its velocity VB will be tangent to this AB link, right? So VB will be in this direction. So we can show the VB velocity vector here at link AB. So this is our velocity VB, and similarly we can show the same velocity here as well. So at point B, this velocity VB, this is perpendicular to this AB arm, and similarly if we show that here, that AB, so we will have that same VB here as well. So here this is VB and this is VB. So this link AB is making 45 degree angle here. So if we draw a line here, then this angle is 45 and this whole angle is 90, then this VB is making 45 degree angle with the horizontal as well. So we can say that this angle is, this VB is making 45 degree with the horizontal as well. So here we have this angle is 45 and this angle is 45. So now we can write that that relative motion equation, relative velocity equation. We can say that velocity of C, this will be equal to velocity of B plus velocity of C relative to B. And as we can see that when this link AB will move in the counterclockwise direction, this block C will come towards the left and this will go up, this point B will go up. So this end B of BC will go up. So this means that this BC link is moving like this in the clockwise direction. So we can say that omega BC is in the clockwise direction. So let's say this is omega BC. If you guys are not sure about the direction of omega BC, so our answer will tell us whether this omega BC is right or not. The signs will tell us. But from now we can think of that if this point B is moved in this direction, so this end B of this BC will go up. So what will happen is that it will appear that this C has moved in the downward direction and this point B has moved in the upward direction. From our point of reference, it will look like this. So now we can say that VC, so VC is VC vector is in the negative I direction if this is our positive X. So we can write that this will be minus VCI, and its J component is 0. So we will write that 0J. Now VB, so VB will have two components. It will have one component in the negative X and it will have one component in the positive Y, and it is making 45 degrees. So we will have this component is VB cos of, so VB cos of 45 degrees, and this is in the negative I direction, and it will have one component in the positive y direction, and that will be the sine component. So you can say that VB sine of 45, and that is in the positive j. Similarly, we always know that this relative velocity of c relative to b is due to this omega bc, right? Due to the angular velocity of length bc. So we can always write this velocity is plus omega bc. And if we are assuming that omega bc is in the clockwise direction, so if we curl our right hand fingers in the clockwise direction, so the thumb will point out towards the screen. So towards the screen is the negative k direction. So we will write that this is minus k. So this is in the minus k direction. And similarly, multiply by the RCB. That will be the position vector from B to C, right? So the position vector from B to C will be this vector. So let me show that vector here. So that will be the position vector from B to C. So the position vector from B to C. So this is RC relative to B. So this RCB tells us the position of that block C relative to point B. So now we can write this equation as minus VCI plus 0J minus, and we know VB magnitude as well, right? So if this VB is only due to the angular velocity of this link AB, which is 3 radian per second, so VB magnitude will be, we can say that VB magnitude will be omega AB times that AB length. So that AB length is 0.5. So omega AB is given, which is 3 radian per second. So 3 into 0.5 will give us 1.5. And this will be in, since 0.5 is in meters, so this will be meter per second. So omega VB magnitude is known, right? This VB magnitude is 1.5 meter per second. So now we will use that magnitude here. So this will be 1.5 cos of 45 I plus 1.5 sine of 45 j, and here we need to apply the cross product, and we need to write this RCB as a Cartesian vector. So this will be, we can write that this is minus omega BCK, and that position vector from B to C is, the magnitude of this link BC is 1.5. So that will be 1.5 times positive I, since it is in the positive I. So again, we can write that the same equation, and this will be equal to plus, and now omega BC into this. So this will be minus 1.5 omega BC and K cross I. So what is K cross I? Let me draw this circle. So this is I, J, and K. So I, J, and K. So if we look into this, so then K cross I will give us positive J. So this is actually, we get minus 1.5 omega BC, and K cross I is J. So now we can compare both sides of the equation. We can equate I term with I and J with J. So we can write that this minus VC is equal to this. So minus VC is equal to minus 1.5 cos of 45 degree. In the problem statement, we are only required to find the velocity of block C, right? So this gives us the solution. But if we were asked to find omega BC, so we can further compare the J components. So from this we get VC. So VC will be equal to, minus sign will cancel out, and VC will be equal to 1.5 cos of 45. So we can write that VC is equal to 1.06 meter per second. And similarly, if we compare the J terms, so this will be 1.5 sine of 45 minus, we can write that 1.5 sine of 45 minus 1.5 omega BC. This is equal to 0, since on this side the J term is 0. So now from this equation we can write that minus 1.5 omega BC is equal to minus 1.5 sine of 45. Minus will cancel out, 1.5 will cancel out. So omega BC is sine of 45, which is 0.707. Sine of 45 is 0. Radian per second. So this is the velocity magnitude of block C, 1.06 meter per second towards the left. And this is omega BC, 0.707 radian per second in the clockwise direction. Remember, if the answer was negative, then the assumed direction will be not accurate. So then we will say that the omega BC is in the opposite direction. If here the answer was negative, right? So now the answer is positive. The assumed direction of omega BC is right as well. So omega BC is in the clockwise direction. We can write that this is clockwise direction. Magnitude is 0.707 and VC is towards the left of magnitude 1.06 meter per second. Now in the problem statement, we are also asked to sketch the position of link BC when theta is 60, 45 and 30 degree. So let me draw the approximate diagram. So first of all, let me copy this. This is the free body diagram. So initially the angle is, this angle is 45. We are asked to draw the diagram at theta equals to 60 and 30. So we can draw that approximately. So let's say at 60 degree, this will be our 60 degree like this. And this will represent our AB arm like this. This will represent AB. This blue line now represents AB. And similarly, we are asked to draw at angle 30. So let's say that this is our angle 30. This red one will represent AB arm at an angle of 30. And as we know that this path of B will be along a circular path like this. BC will look like this and this will look like this. So let's draw just an approximate length for that. So this will be our BC, somewhat like this, and this will be our BC, somewhat like that. But if you guys want to draw the accurate diagram, so then you need to select a scale, and then according to scale, you guys need to draw a length AB of 0.5 meters. And let's say that if you guys assume that 2 centimeters is 0.5 meters, so then 1.5 will be, we can say that if 0.5 meters is equal to 2 centimeter, 2 centimeters, then 1.5 will be 2 divided by 0.5 into 1.5. So that will be 6 centimeters. So 1.5 will be 6 centimeters. So then you guys need to draw a line from point A of length 2 centimeter that will represent AB. And then from point B, you guys need to draw an arc of 6 centimeters. So then joining that point B with C will give us the exact diagram, the exact sketch of the mechanism at these 3 angles. So this is the solution of this particular problem. I hope this will help you in your learning. Do subscribe Engineers Academy for the solution of such more problems from Hibbeler Dynamics.